Hey everyone, welcome back. Today we're going to look at the ambiguous case of the sine law. So angle, side, side. When given angle A, side B, and side A in a triangle ABC, different possibilities occur. And today we're going to explore these cases. So first thing, set your calculator to degrees, and we're going to calculate all values to one decimal place. So we're going to fix angle A and B and then consider different values for A. Okay, so this is an important thing. Go ahead and copy this down. We're going to use H throughout this lesson. Right, so angle A is given, side B is given, and then A is opposite of angle A, right? So it's like over here. And this H value, we get it from SOHCAHTOA, right? Sine A equals opposite over hypotenuse. So sine A equals H over B like that. We can isolate H time B, so H equals B sine A. And go ahead and copy this down because we're going to use that today. Okay, different possibilities. Here we go. If angle A is acute, right, less than 90, we can have A being less than H, right? So here's our side A being less than H. This gives no triangle. So all of these cases that I'm going to share with you, go ahead and copy them because we're going to be referring to it throughout the lesson, right? So go ahead and copy this down. Okay, the next case, we have A equal to H. This gives one triangle. It's a right angle triangle. The next case is if A is bigger than H, right? So you see how it's a bit bigger than H, but less than B. This gives two triangles, ABC like this, but also another triangle, AB prime C like that. And both are given the same initial information. And other one here, we have A greater equal to B, and this gives one triangle. Okay, so make sure you copied all of these four cases down, okay, right? 1, 2, 3, 4. Another case is if A is obtuse, right? So greater than 90. If A is less or equal to B, then we have no triangle, right? You see this, it doesn't reach to the other end here. If A is greater than B, then we have one triangle, like that. Okay, example 1. Solve all possible triangles with the given information. So here we have angle A 35, B is 6, A is 8. We notice that A is greater or equal to B, so this gives one triangle. So we're going to draw a triangle like this, right? So angle 35, A is 8, and then B is 6, like that. So we have side B, but we don't have angle B. Right, so we're going to use the sine law here like this. Sine B over side B 6. Sine A 35, right? Sine 35 over side A, which is 8, like that. Times 6 to both sides. Sine inverse to both sides like that. The sine inverse and sine cancels out as we've seen previously. So angle B is sine inverse of this, which gives 25.5 degrees. Okay, so with angle B and angle A, we can get angle C, right? So 180 minus 35 minus 25.5, and so angle C is 119.5. We have angle C, but not side C, so we're going to go times sine of 119.5 to both sides. So side C, punch that in, and that gives 12.1. Okay, next example, B. Angle A is 40, B is 6, A is 3. H is B sine A, which gives 3.86. A is less than H, therefore we have no triangle. Okay, C. Angle A is 45, B is 2, A is root 2. H equals B sine A, so B is 2 sine of 45, which gives root 2 over 2. These 2's cancel, so H is root 2. So we have A is equal to H. This means one triangle. It's a right angle triangle. Right? So B is given. 45 is given, and h root 2, or a root 2. So we have 90, 45, and the other angle is 45, like that. We're going to use the Pythagoras Theorem, right? So we notice that side c squared plus root 2 squared equals 2 squared. This gives c equals root 2. Okay, D. Angle A is 35, B is 8, A is 6. We calculate H to be 4.6. So we notice that A is greater than H but less than B. So we have two triangles. Right? So I'm going to draw the two triangles right here, right? A, B, C like that, and A, B prime C. So we're going to consider the first triangle, A, B, C. So I redrew it like this here. We're going to get angle B first, because we have angle A and side A, and then we have side B but not angle B. So times 8 to both sides, sine inverse both sides, angle B 49.9. With that, we have 35 and 49.9, so this gives us our C value, 95.1 degrees. We're missing side C here, but we do have angle C. So we times that to both sides, C equals this, and which gives 10.4. Okay, this is our second triangle, A, B prime C. We already know this was given to us. This is 6, like that. We calculated 49.9 to be this angle, which is the same as here, because it's an isosceles triangle. And so this angle B prime, we do 180 minus this angle, 49.9, like that. And so this gives 130.1. So with our 130.1, we can get angle C. 180 minus 35 minus 130.1 gives 14.9 to be this angle there. We don't have side C. So side C over sine 14.9 equals 8 sine 130.1. Move the sign over here like this, calculate C, and we get C to be 2.7. Okay, time for some practice, lots of practice. Solve all possible triangles with the given information from A to E. Go ahead and pause the video and answer that. Okay, we're back. A, angle A is 40, B is 7, A is 4, H is 4.5, A is less than H, therefore no triangle. Okay, B, angle A 37, side B is 5, side A is 8, A is greater than B, therefore there's one triangle, and here's the drawing. We have side B but not angle B, so here's our setup here. Times 5 to both sides, sine inverse to both sides, angle B is 22.1. So we have angle A, angle B, so we're going to get angle C by going 180 minus 37 minus 22.1, which gives 120.9. We have angle C but not side C, and we have A and sine A like that. Times sine 120.9 to both sides. This is our value of C calculated, and that gives 11.4. Okay, C. Angle A is 60, B is 2, A is root 3. We calculate H, we get H to be root 3, so H equals A, therefore one triangle, and it's a right angle triangle. We know angle B is 90 degrees. A is 60, as given. Therefore, C is 30. And we're going to get side C from Pythagoras Theorem. C squared plus root 3 squared equals 2 squared. And this gives C equals 1. Okay, D. Angle A 31. B is 7, A is 4. calculate h, and we get 3.6. So we have 3.6, 4, and 7. Therefore, there are two triangles. Here they are like this. We're going to start with ABC. So I just drew it again, what we know, ABC like that. We have angle A, side A. We have side B, but not angle B, so we're going to set that up like this. Times 7 to both sides, sine inverse to both sides. Angle B is 64.3. We have two angles, so we can get the third. 180 minus 31 minus 64.3 gives 84.7. We have angle C, but not side C, so we're going to rewrite that here using our sine law. Times sine 84.7 to both sides. Here's our C value. We punch it in, and we get 7.7. Okay, our other triangle, AB prime C, like that. We already calculated that this is 64.3. So this is 64.3 because it's an isosceles triangle. And so B prime is 180 minus 64.3, which gives 115.7. We have A and B prime, so we can get C like that. All that's missing now is side C. So we have angle C like that. So times sine to both sides, and we get C value of 4.3. Okay, last is E. Angle A 110, B is 6, A is 9. Angle A is obtuse. Here's our drawing like that. We have A greater than B, so it's one triangle. Here is our triangle. We have angle A and side A like that. We do not have angle B. We have side B, but not angle B. So this is our setup here. Times 6 to both sides, sine inverse to both sides. Angle B is 38.8. So we're going to get angle C by going 180 minus 110 minus 38.8 gives 31.2. We don't have side C. So we're going to times this to both sides. C is this here. We punch it in and we get 5.0. And that's it. It's that easy. I'll see you guys in the next lesson.